Today, we're going to learn how to use the stack data structure. Hello, I'm James Helfrich. The stack data structure is useful for the first in, last out way of access data. In other words, we can only access data on the end of the stack. This video will demonstrate how to use the various methods included with the stack's standard template library implementation.
There are several ways to create a stack: the default constructor, the copy constructor, the move constructor, and we can also specify the underlying container. So we're going to start by creating a stack. Now we have to pound include stack, and the full name of the stack is std::, because it's a standard template. Stack, we specify the data type int and s. And when I run this, I'm going to have a stack of size 0. There are no elements. Okay. Now we can also specify the data that goes into the stack, and we do this by passing in an initializer list or any other type of iterable. In this case, 2, 5, 9, and 11. And when I run this, I'm going to find out that I have 4 elements in the stack, and notice how the last element is at the end or the tail of the stack. Okay, so I'm going to call this guy the source, and now I'm going to create a new stack called the destination. Okay, and let's see here, which constructor. This is also the initializer list constructor, but you know what? I think what I'm actually going to do here is the copy constructor. So I will get rid of that list there, and I'll put s of source. All right, now when I run this, I expect to have 2 copies of 2, 5, 9, and 11, 2 stacks of size 4, and sure enough, I do. So the copy constructor works. Next, we'll do the move constructor and go std::, move, and that's going to indicate that I want to steal the elements from a source and put it into destination. Therefore, source will have 0 elements in it, and destination will now have the 4 that belonged to the source. And sure enough, that's the case. All right. One cool thing I can do about the stack is I can create, it's called a container adapter. I can create a stack out of a vector, or out of a deck, or out of a list. And so what I'm going to do is I'm going to specify the data type of the underlying container as a template parameter. All right, so first of all, I'll have just a normal stack that's empty. And this is going to use, it turns out the deck is the underlying container, but that's less important. Now I'm going to say stack of vector, and I'm going to create this one out of std::, vector of int. So now this will be created out of the vector, and I'll do the same thing for the deck and do same thing for the list. Really, any container will work as long as it has a pushback, which we'll use for push, a popback, which we'll use for pop, and a back, which we'll use for top. As long as it has those, then we can use it as the underlying container. Now when I run this, it all compiles, and it will behave exactly the same, though with slightly different performance implications. In each case, I'm going to create an empty stack. Okay, so now I'm going to use the assignment operator, the move assign, and the swap. Okay, so I have 2 stacks, the source and the destination. The destination has 2 and the source has 5. So if I say destination assignment operator source, then I'm going to copy the elements from the source into the destination, and now both will have 5 elements. Notice how the 2 elements that were initially in destination are now gone. Okay, now that is the copy assign. I can also do the move assign, and I can specify this by saying std::, move on the source. And what will this do is it will steal the elements from the source and put it in the destination, much like the move constructor steals the elements from the source. And when I run this, sure enough, I'm going to see that the source is now empty and the destination has 5. And the final thing I could do is I can swap the elements from the source to the destination. In this case, initially source has 5 and destination has 2, but after I swap it, then source will have 2 and destination will have 5. And sure enough, that's the case. The stack does not have an iterator, and it only has 2 access methods, top and top const. So we're going to first by accessing the top element, and this is going to be a top const, and this is the read-only version. And this will allow me to look at the top element of the stack and not modify it. Now the top element is the last element, which in this case is the value 11. And when I run it, sure enough, I'm going to have access to the value 11. There we go. Now I can also modify the top element because top is a read-write as well. In this case, I'm going to put the top element as 211. And when I look at my new stack, we're going to realize 111 is in fact the top element. Stack allows me to add an element onto the back of a stack using push, both copy push and move push. Okay, so I'm going to start with my same 5 elements, and I'm going to push the value 13, and I'm going to push the value 17. All right, when I run this, we're going to see that now I have 7 elements, and the last 2 elements are 13 and 7. I can only push elements onto the end of the stack. Pop only provides one remove method. It's called pop. I don't even have a clear. So with this pop, I just say s.pop, and this will remove the last item from the stack. If I try to say clear, then I'm going to get a compile error. So notice when I run this, we'll see that I now have 4 elements on the stack, and the element 11 is now missing. I have 2 access methods. One of them is size, and the other is empty. So I'm going to say s.s1 si's size, and e is empty, and I expect size to be psi to be 3 and empty to be false. And when I run it, sure enough, that's the case. Si is 5, and then e is false. Learn more about the stack data structure in the C++ Data Structures textbook.